Alright, for this next hint, we're going to write down the equations of motion for the two vehicles. Alright, first I'm going to start with what we know. We know that for the police car, whoops, didn't mean to move that, for the police, our initial velocity, v0, is 0, and the acceleration is 4.51 meters per second squared. We know that for the speeder, initial velocity is 17.9 meters per second, and acceleration is constant at 0. I'm going to show you how to set up both equations using my favorite kinematic equation. This equation is not always useful, but it is my favorite because it covers like 80% of the problems you'll ever be asked to solve. This is equation 211 from page 46, and it says position, final position, equals initial position plus initial velocity times time plus 1/2. Also, you're now seeing why I make my t's curly, because otherwise they get confused with plus signs. 1/2 acceleration times time squared. This equation is my favorite. Any problems that I write myself will probably be you'll use this equation. The AP exam doesn't necessarily have a favorite equation of motion. This one I love, and if you are willing to work at it, you could memorize this equation and solve almost every kinematic problem. Some of them get confusing, but this equation can do almost all of them. It is my favorite. Alright, now let's do it for each one. And in my diagram earlier, the speeder was the red color and the police car was blue. So let's do the police first. Alright, final position of the police car equals the police car's initial position, and we're calling both of their starting places at the origin, so that's just 0. So notice I'm just filling in the equation. The police car's initial velocity is also 0, and we have the police car's acceleration, 1/2 a police. And I know we know the number, but I'm going to stay away from that for the moment. Solving with variables is always better. The reasons I put in zeros over here is just to see that I could eliminate that. So now, let's have the police car's equation of motion simplified as 1/2 acceleration of the police car times t squared. Alright, I've cleaned it up. In purple is the equation of motion, and then I just wrote the police car down at the right-hand corner for reference. In my original diagram, the speeder was red, so let's do the speeder next. Final position of the speeder. Alright, I'm looking back at the problem because I did erase the givens. So you might want to look back at the last slide. The speeder had an initial position of 0. We agreed they were both 0. And the speeder's velocity was 17.9 meters per second. Let's not write that. I'm just going to leave it as v0 and a little s for speeder times t plus 1/2. The speeder does not speed up or slow down, has a 0 acceleration, 0 t squared. Filled in the zeros. Oh, I forgot my equal sign. Filled in the zeros just to show you what could be eliminated. So now the final position of the speeder simplifies to v0 s for speeder times t. So what started out as probably an intimidating equation has now reduced down pretty simply for both. We've got an equation for the speeder and an equation for the police car. On the next slide, I will set those equal to each other and help you solve for t. Alright, here are the two equations, and now I'm going to set them equal to each other in one big equation. And so I'm using the fact that I know their positions will be the same when the police car catches the speeder. Positions will be the same. So now I'm going to take the speeder's equation, put it on one side, v0 t, take the police car, put it on the other side, equals 1/2 a t squared. And then I'm going to solve for t. This is a second order equation. If you don't know what that means, notice that it is to the second power, one part. That means there are two solutions to this equation. I would like you to try to find both solutions without plugging in numbers. So find both solutions without plugging in numbers. Pause if you want to. And then I'm going to tell you what the two solutions are. I'm not going to show you how to get there. That math you do need to do on your own. All right, the two solutions when you solve are t equals 0. Try that out. If I plug in 0, over here this side becomes 0 and this side becomes 0, so obviously that's true. Remember I pointed out to you we would find this solution. I pointed that out in, I think, hint 1. This is the starting point. We know that they're at the same place at the starting point when the speeder initially passes the police car. The other solution that you should arrive at is t equals 2 v naught, and remember that's the speed of the speeder, divided by the acceleration of the police car. And then it's just plugging in the original numbers looking back at the problem. So take a little while if you weren't able to do that math on your own and figure it out. Call me, call a friend, text me, whatever. You should be able to get from this equation down to these two solutions. I want to force you to try it. I don't want to just hand it to you. Remember I talked about dragging you through the hard stuff so you remember it. This is one of those cases. There's the answer. Try to get to it using algebra. Hint, if you already know one solution, even though it's kind of poor form, you can cancel one t with another. So you could cancel the t squared with the t on the left side and just have one t. Anyway, that's probably too much info. In the last hint, I will show you how to get the distance and velocities, which were the last things we needed.